Hello, room 13. It's Miss Martinez here again. I hope everyone had a wonderful weekend and everyone is safe and healthy in their homes. Let's see what we're going to be working on today. Today we're going to be working on lesson 11, and our objective today is, it says, explain fraction equivalence using a tape diagram and the number line, and relate that to the use of multiplication and division. Okay, so before we get started, I want to show you something. I'm going to go ahead and write this. So these are our tape diagrams, okay? Now, the first thing I want you to see here is in my first tape diagram here, I cut it, and it looks like I shaded this part, and looks like I made half, right? Half of it is shaded. Do we agree or disagree? So, what if I decide to decompose my tape diagram? What if I decide to decompose it into, and I want to make fourths. Well, if I take the same tape diagram here, and I'm going to shade this part. I'm going to be starting with the same one. And I want to make fourths. Well, can't I just decompose it and cut it here? And if I do it here, I'm going to do it here because I want all my parts to be equal, right? So it looks like I made fourths. 1, 2, 3, 4. I made fourths, right? But now I don't have half shaded. How much do I have shaded now? I have 2, right? I have 2 fourths shaded. Do we see that? Now, what if I want to make eighths? How can I do that? How can I do eighths? Well, I'm going to go ahead and shade this. And I'm going to go ahead and copy this. I'm going to make my fourths here. These are my 2 fourths. Well, what if I see here I have 2 fourths and I decompose it even further? What if I do this? I'm going to cut each part in 2. And I'm going to do the same thing, right? Because I want the tape diagram to be equal. Does it look like, excuse me, does it look like I made eighths now? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Sure did. I made eighths. How many parts of those eighths are shaded now, though? 1, 2, 3, 4. 4 eighths. So that means that 1/2 must be equal to 2 fourths, and it's also equal to 4 eighths, right? I have equivalent fractions. And if we pay very close attention to my tape diagrams, I can see here that isn't this piece the same as this piece? Same thing, right? I just cut it in here. I just cut it in two. And isn't this piece the same as this piece here? I just decomposed it further, right, to make eighths. So this is equivalent to this. This is equivalent to this. That means that this piece is the same thing as this piece, right? We know that, right? All the fractions are equivalent. What do we think? Now let me show you something else. This is a number line. And first I started with my tape diagram, right? And I decomposed it to show equivalent fractions. Well, what if I tell you that we can decompose a number line to do the same thing? So here I have my number line and I have thirds, right? You can see we have thirds here. Agree or disagree? One, well, this is 0. 0 thirds is 0, right? This is 1/3, 2/3, 3/3. This is my whole fraction, number line. Well, what if I tell you, let's decompose 1/3 into 4 parts. What if I tell you, let's decompose 1/3 into 4 parts? Okay, well, this is 1/3. Okay, agree or disagree? Is this 1/3? Okay, right? And I want you to decompose that into 4 parts, into 4 equal parts. Okay, no problem. So I'll use my different color marker. I'm gonna decompose this into 4 equal parts. So, let's see. Did I decompose that into 4 equal parts? Let's see, did I make 4 parts in here? Let's see, 1, 2, 3, 4. Yeah, looks like I did, right? And remember that when I did that to my tape diagram, here, when I decomposed it, I can't just do one side, right? I have to do it to my entire tape diagram. So let's do that. Why don't we do that to our number line 2? If I separate this 1/3 to 4 parts, shouldn't I do the same thing here? Sure. One, 2, 3, 4. Check. One, 2, 3, 4. Check. Okay. But now I could say that my whole number line is no longer cut into thirds, right? After I decomposed it, looks like I made, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now my whole is 12. So that means that, I'm gonna go ahead and write it here underneath. That means that my 0/3 will be 0 what? If I changed my number line, if my whole is no longer 3 and now it's 12. twelfths, right? Agree or disagree? And this will be, I could say this could be my 4/12. And this will be 8/12. Wait a minute, Miss Martinez. Stop. What are you talking about? Well, let's see. Remember now my whole's 12, right? So 1, 2, 3, 4. That's why I wrote 4/12 here. Got it? 8/12. Wait, where did Miss Martinez get those 8/12? Oh, that's right. She's counting the, after she decomposed, she's counting the 12ths now. 1, 2, 3, 4, 5, 6, 7, 8. Oh, got it. That's where she got it from. Now, 8, 9, 10, 11, 12, right? And we know that 12 out of 12 is 1, right? Just as 3/3 is 1 whole, 12/12 is 1 whole. Okay? Do we agree or disagree? So that means that 1/3 must be equal to what? 4/12, right? And I can even use multiplication to do that. And I know everyone can do that, right? Because that's what we've been doing the past few weeks, right? But if, let's see if I multiply times 4, 1 times 4 is 4. And if I do it to the top, I have to do it to the bottom. You got it. Agree or disagree? What do we think? Okay, let's move on and see what our problem set looks like today. So it says, label each number line with the fractions shown on the tape diagram. Circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. Okay. So I went ahead and I just did the problems. They're exact the same thing you have on your paper, on your assignment, but I just did it a little bigger because it makes it easier for us to understand. Okay? So the first thing I see here is they're telling me, I see the little arms. Remember the little arms I told you? Pretend that these are little arms that are hugging the tape diagram. That means that all this is 1, right? It's 1 whole. Agree or disagree? Now, first, the second thing I'm going to do is I'm going to count to see how many parts are in my whole. Let's see. 1, 2, 3, 4. 4 parts. So I know that my denominator is going to be 4. Right? So I'm going to go ahead and label. I'm going to go ahead and label my number line. If I look over here, I know that this will be 0/4. And we know that 0/4 is really 0, right? I'm going to go ahead in here and write 1/4. I'm going to go ahead and write here 2/4. I'm going to go ahead and write 3/4 and 4/4, which means the whole, right? Agree or disagree? So they're asking us to circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. Okay, well, what part of the tape diagram is shaded? We know that, right? We know it's 1/4, right? So I'm going to go ahead and I'm going to circle 1/4 because 1/4 of the tape diagram is shaded in. And I have it here on my tape diagram, and I have it on my number line. And I'm going to go ahead and I'm going to label it here. This is 1/4. Let's go ahead and do B together. Well, Miss Martinez, what can I do? What can I do? I know that this is 1, right? Because I see the little arms. Let's see. Let's count to see what our whole is, right? 1, 2, 3, 4, 5, 6, 7, 8. 8. 8 is my whole. So I know I'm going to use that as my, yep, you got it, denominator. So that means that my number line is going to be labeled with 8s. So I'm going to go ahead and label my first line on the number line. What should I put here? Well, let's see. Looks like it's going to be 0, right? What do we think? Agree or disagree? And you know what? I can even be sneaky and go ahead and label the last one because I know my whole is 8th. So I know that it's going to be what? 8, right? 8/8 because that's one whole. That's my whole tape diagram. That's my whole number line. After I do that, I can go back in and fill in, right? So this is 0/8. This is 1/8. 2/8. 3/8. 4/8. 5/8. 6/8. 7/8. Agree or disagree? And now I can go ahead and circle my fraction on my number line that represents my tape diagram. How much of my tape diagram is shaded, boys and girls? Let's see. I know I have 8, and we see 1, 2. 2/8 are shaded. So I'll go ahead and circle 2/8. And I'll go ahead and write here, 2/8. Agree or disagree? Now, if we pay even closer attention, are you ready? Guess what, boys and girls? It looks like our tape diagrams. Well, this part, is this equal to this part? Looks like it is, right? Wait a minute. Does that mean that 1/4 is equal to 2/8? And this is actually this is actually number 2, what I'm about to show you. Number 2 on your assignment. So you can go ahead and say 1/4 is equivalent to 2/8. And if we use multiplication, I can say that, 1 times 2 equals 2. And if I do it to the top, I have to do it to the bottom. 4 times 2 equals 8. Check? Yep. And if I even pay more close attention, I can see that here, my 1/4, I decomposed it to make 8. I decomposed it and I did each part. I cut it into 2. Can you see that, boys and girls? Here, if you bring your eyes down here, you could see that this, I just cut it in and made 2 here, right? This, I cut it in 2 here, right? This one, looks like they cut it in 2. This one, they cut it in 2 to make 8ths. What do we think? Agree or disagree? Awesome. So go ahead and try C on your own and see if you can find another equivalent fraction. Interesting, interesting. Let's see. Let's go ahead and look at number 3. It says, use each shaded tape diagram below as a ruler to draw a number line. Mark each number line with the fractional unit shown on the tape diagram and circle the fraction that labels the point on the number line. That also names the shaded part of the tape diagram. Okay. So, you know that Miss Martinez redrew it with her beautiful art, right? To make it easier for us to understand. So, we have a tape diagram in number 3A. And the first thing I want to do is, well, I see that this is one. This is my hole, and it looks like I have 1, 2, 3. I have 3 parts. Now, they want me to draw my own number line now. Okay, sure, let's do it. So I'm going to go ahead and draw my number line. I'm going to do an arrow here. And I'm going to do an arrow here. Good? Everyone with me? Okay, wonderful. Now, I know that I'm always going to begin with 0, right? And you know what? You can line up the line to the edge of the tape diagram. That always helps. And I know it's going to be 0. Oh, wait a minute. What's my denominator? Oh, right, 3. Because I have 3 parts in my tape diagram. Got it. And remember I said we can go ahead and be sneaky and go to the end because we know that this is going to be, yep, you got it, 3/3. That's 3/3 is my whole, right? Now I'm going to go ahead here and I'm going to align my tape diagram to my number line, and that looks like it's going to be 1/3. And what do we think this one's going to be? Yep, you got it. 2/3. Now they want us to circle the fraction that represents our tape diagram. Well, 1, 2, 2/3 are shaded in. So I'm going to go ahead and do that. I'm going to go ahead and circle my 2/3. Okay, should we try to do B together? Sure, why not? So, I'm going to start with my number line this time because I know I have to do a number line. So I'm going to go ahead, draw my line with my 2 arrows on the end. Now what? Oh, Miss Martinez, count to see how many parts are in your hole. Oh, good idea. 1, 2, 3, 4, 5, 6. I have 6. Okay. No problem. I see. So I know that my hole is 6. So I'm going to go ahead and start labeling my number line. Well, I know that I'm going to line up my number line with the edge of the tape diagram, and I know I'm going to always start with 0, 6, right? And should we be sneaky and go ahead and do the end of it? Sure, why not? We know that it's going to be 6, 6. Now I can go ahead and fill in the rest. So this is going to be 1/6, 2/6, 3/6, 4/6, and 5/6. Good? Okay. Now, how many parts are shaded out of my 6 in my tape diagram? Let's see. 1, 2, 3, 4. 4 sticks. So I'm going to go ahead and circle this because that's what they want us to do, right? And I know that in number, let's see the next one, number 4, they're going to ask you to go back to this and use division now to show the equivalent fractions. How can I show that 4/6 is equivalent to 2/3 using division? Can I say 4/6 is equivalent to 2/3 using division? Sure. How can I do that? Well, let's see. What if I do this, boys and girls? If I divide by 2. And remember, if I do it to the top, I have to do it to the bottom. You got it. 4 divided by 2 is 2. 6 divided by 2 is 3. What do we think? Agree or disagree? And we know that if we look carefully, right? If we look carefully at our tape diagrams, we know that here are 1, 2, 3, 4 parts here. If we divide them, it looks like we get 2, right? Do we see that, boys and girls? Agree or disagree? Wonderful. Go ahead and try to do C on your own. And let's go ahead and, why don't we do 5? Let's do 5A together. Let's see. Directions. It says, partition a number line from 0 to 1 into fifths. Decompose into 4 equal lengths. Okay, Ms. Martinez, what do I have to do here? Okay, let's do it together. So the first thing is, it says that they want us to write a number line and they want us to do fifths. Okay, let's do that. So I'm gonna draw my number line, and this is for number 5A. Good. Do my number line. And now they want us to do, they want us to do fifths. Okay, I can do that. Well, I'm gonna start here. I can do that, and I know I'm gonna start with 0, right? And I can go ahead and come back here. I'm gonna go forward a little bit, and I know that it's gonna be my 5/5. And now I can go in and fill in my number line. I could say this is 1/5, 2/5, 3/5, 4/5. Agree or disagree? And then it says decompose 2/5 into 4 equal parts, into 4 equal lengths. Okay, I can do that. Okay, so 2/5, decompose 2/5. So I'm going to go here. I see my 2/5 here. And they want me to decompose that into 4 equal lengths. Okay. Oh, yeah, I remember. Let's do 4 here. How can I make 4 equal parts in my 2/5? For my 2/5? Well, what if I do this? Did Miss Martinez decompose these 2/5 into 4 equal parts? 1, 2, 3, 4. I sure did. And remember, if I do it to this part, I have to do it to the rest of my number sentence, right? Just like when we do for our tape diagram. So I'll go this way, I'll do this, I'll do this. Agree or disagree? Now B is asking me to show multiplication to show a fraction represented on the number line that's equivalent to 2/5. Okay. Well, they want me to show that, so I can go ahead. I'll write 2/5. And it's going to be equivalent to, well, if I look here, looks like I separated each into 2, right? There's 2 here, 2 here, 2 here. What if I would multiply times 2? Let's see. Can I do that, boys and girls? And if I do that, if I multiply to show an equivalent fraction, I know that 2 times 2 is 4. And 5 times 2 is 10. What do we think? Well, let's see this a little. Let's put on our thinking goggles and think. Well, after I decomposed it, let's see, how many parts did I do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay, Miss Martinez. Now I see. So after I decomposed it, I made tenths. I no longer had fifths. So that means that this, which was my 2/5, is now my 4/10. 1, 2, 3, 4. So this is 2/5 and 4/10 after I decomposed, right? That's why they're equivalent fractions. Okay? Go ahead and try the rest on your own. I know everyone will do an awesome job. Take care, Room 13.